Hello, this is KP the Math G. Once again, I want to say it's either going to be for the 89th time or the 90th time. I want to say this is the 90th video, but I have to check. I want to say the last video was the 89th video. I want to say this is the 90th video. But anyway, we have a problem from 1999. The free response question number 1, and just to abbreviate everything, where from the last video we did parts A and B. A having to find the velocity, or actually in which direction is the particle moving at time t equals 1.5. We found it was moving up because v at 1.5 is greater than 0. The acceleration, of course, we had to take the derivative of this, and we did that yesterday. The question was, is the velocity of the particle increasing at t equals 1.5? Well, v prime at t was negative, and so we determined from that answer that the velocity is decreasing at t equals 1.5, which leads us to point C. Given that y at t is the position of the particle, the position. Now we're talking about the position and distance and so on. When you get down to position, you want to say, well, okay, let's read the rest of it. The position of the particle at time t, y at 0 equals 3, find y at 2. Well, position means, well, do we take the derivative or do we take the antiderivative? Well, you know, if we took the derivative on part B, that was to find the acceleration, right? But at part C here, we're to find the position. Okay, we want to find y at t. We have v at t. So to change that, we want that to be equal to, we have to, if we want it to be y at t, we need to take the antiderivative. That's correct. I'm going to do this by hand. So we don't have really a definite interval. We don't say from 0 to 3 here. We're going to have a plus c on the end of this one. And so we have t sine t squared dt. This is a very doable problem. It's done by substitution. When you think about it, this is really nice because this is t squared and this is t. Actually t dt, right? Think about that. Alright, so if you have one where the exponent is 1 greater than what you have here, then you can do this by substitution. So let's let t squared, let u be equal, let's say u be equal to t squared, du is equal to 2t dt. We got t dt, we just want to get rid of this 2, don't we? We got 2t dt here, we need just t dt. Alright, so we're going to multiply by half both sides. That divides out. So 1/2 du is equal to t dt. I did a video on this one. I don't know which one of the videos I did that on. Could have been the 37th one. I don't know. But anyway, 1/2 goes out in front. Alright, so I've got 1/2. Alright, now sine of u du. Simple as that, isn't it? keep in mind that the antiderivative of the derivative of sine is cosine, but the antiderivative of sine is negative cosine. So I'm going to make this 1/2 a negative 1/2. That's where the negative's coming from. And then cosine, well, I don't need that. Cosine of u. Now, of course, instead of saying u, I'm going to put t squared. And then I'm going to put a plus c on the end here. Like that. Alright. And that is equal to y at t. Okay? Alright. But now I know what y at 0 is. Alright? Y at 0 is 3. That is, t is 0 and y at t is 3. Alright, so let's flip this over. Negative 1/2 cosine t squared plus c. Here we go. 3, 0. Okay. So 3 is equal to negative 1/2 cosine of t squared, which in this case is 0 squared, plus c. Now remember, going back over here, oops, looking at it again, I want to make sure I'm right. Alright, negative 1/2 cosine t squared plus c. Y at 0 is 3. Alright, that's what I did there. Putting 3 here and this here. That's how you set it up. Alright, so let's see. I can probably, well, let's see. 3, negative 1/2. Cosine 0 squared is the same as cosine 0. Cosine 0 is 1, isn't it? That does like this. Okay, so cosine of 0 is 1. Alright, so 1 c. Alright, so 3 is equal to negative 1/2 plus c. And then we'll add 1/2 both sides. 1/2. 1/2 both sides. So actually this is 3 plus 1/2, which is 3 1/2, is equal to c. So now my problem becomes this now. Y at t is equal to negative 1/2 cosine of t squared plus 3 1/2, which is, well, we'll just say 3.5 or not 3 1/2. Alright, like that. Okay, that deals with that one there. And then now I need to find, the rest of the problem says find y at 2. Well, I got this. So once we get first of all we have to get the equation, and then we have to be able to plug the number in. So you got to remember that when, let's go back again, that when you see this right here, you know you have to first of all take the antiderivative. This right here gives it away that it is an antiderivative. This is called an initial condition. Y at 0 is equal to 3. And then at the end, you find that c by plugging in 0 here. Not 3 here. 0 here. 0 here. 3 here. Alright, so y at 0 was equal to 3. Alright, that's where you're going to plug that in here. You plug that into t. Alright, and then we solve this, we get this. Now we can find y at 2? Is it y at 2? I think that's the question. It is. So y at 2 is equal to negative 1/2 cosine of 1/2 squared, 2 squared rather. Alright, 2 squared. Alright, plus 3.5. Alright, and this is equal to negative 1/2 cosine of 4 plus 3.5. And if you punch this in on your calculator, you will get an approximation, I think, and we'll get 3.827. 3.827. Alright, like that right there, and that's what you're looking for part C. I want to look at the scoring on that one. Should be quite a few. Well, that's just 3. So 1 for setting up the antiderivative, another one of course for finding C, getting this equation here, and then plugging the number in and getting the answer. Okay, let me erase this part because I can do part D very quickly. This will not take long at all. So let's erase this. That's a good problem. I like doing problems like this. Alright. So the position at time 2 is at x equals 3.827. T is equal to 2. Alright, there it is. And I think since this is going up on the y-axis, that's how far up it's going. 3.8 whatever. Alright, now let's look at D part, which is, again, let's just rewrite the problem up here. We have V at t was equal to t sine t squared. I think that's everything there. Alright, now the last question is talking about find the total distance. So part D, find the total distance. Now, total, I want the absolute value because some parts of the graph may be below the t-axis, and that would be negative. So we want to do this, and let's see what we're talking about here. It is, and we do need from t equals 0 to t equals 2. I do believe that's what it's asking for. Yeah, yep, that's right. Okay. Alright, so t equals 0 to 2. That's why we needed a definite interval. We do want to say the absolute value. Always when we're talking about total distance, absolute value. Okay, that's what you need to do. You can plug this in on your calculator. This would be t sine t squared dt. And of course you can put that into, I don't know, I think like that, yes. And the answer comes out to about, let's see where I did the work at. Okay, yes. It's about equal to 1.173. So you can punch this, if you have this integrand symbol on your calculator, you can easily do this. Figure out where your absolute value is on your calculator and put this inside that right there, just like that. Okay, mine shows the absolute value bars. I can put that inside there, and I can make this go from 0 to 2, and then I can just come up with my answer. Very, very simple. Think about total distance, absolute value of volume. It's going to give you that total distance from time 0, t equals 0, to time t equals 2. Alright, that does that. So, in conclusion, the first one was that we had to, well, we've already did this one, but we had to find the position. Okay, we had to find out what y at t was, didn't we? Okay, and then once we put in that initial condition, we found out that c was 3.5. Plugged that in there, and then we found y at 2, didn't we? Okay, and then on this one here, very quickly, easily, total distance, take that absolute value. Please don't leave off those absolute value bars. That's very important to leave them on. Okay, if every position above the t-axis is positive, you can get away with that. But if you have part of the graph below the t-axis, you're going to need these, okay? Well, anyway, that's all that I have for this morning. This is KP, the Math G again. Please subscribe if you haven't subscribed already. And also, please hit that like. I love those. Make a comment, if you will, about the lesson. I hope that this has been beneficial to you. I trust that it has been, and that's what I'm here for, is to really help you get a grip on this and to understand it. And to really excel, especially those of you who are taking the AP exam. You're in that AP class, and you have to take that AP exam. These are questions that have come off that those prior tests, and just because it was 1999, believe me, I guarantee you can probably go to almost current time and find questions just like this. So don't let that year fool you. Okay. Alright, well, anyway, this is KP, the Math G, signing off. I hope that you and trust that you have a great, great day.